All right, let's talk about chemistry exams. You ever feel like you've got all the knowledge in your head, but when it comes to the test, you just can't seem to get the marks you really deserve? Well, today, we're going to fix that. We are going to break down a real GCSE paper and learn how to turn what you know into solid, exam-winning marks. Let's get stuck in.
Oh yeah, we've all been there. You flip open the paper, your mind goes completely blank, and you can feel that panic start to bubble up. But here's the thing. Every single question has clues baked right into it. It's like a set of instructions on how to get the perfect answer. Today, you and I are going to learn how to read those instructions and turn that confusion into total confidence.
So here's our game plan. First up, we'll learn to decode the secret language of exam questions. Then we're going to put that straight into practice on 3 totally different types of questions. We're talking everything from properties of materials to lab skills. And finally, we'll wrap it all up into a simple, powerful strategy that you can take with you to ace any exam.
Okay, let's get right into the most important technique. Acing an exam isn't just about what you know, it's about proving what you know on paper. And the way you do that is by following these 3 golden rules for every single question.
Think of it like a puzzle. The command word is the action. It tells you what you need to do. The keywords tell you the topic, the specific bit of chemistry you need to think about. And the marks? Well, the marks tell you how many pieces your answer needs. 1 mark? It's probably just 1 simple point. 2 marks? You're likely going to need to make a point and then explain it. Get these 3 things sorted, and you are golden.
All right, time to put this into action. Let's tackle our first question. This one's about materials, their properties, and a little bit of calculation. I want you to pay close attention to how those command words change what the question is asking for.
See this? Look closely. Part 1 says give a reason, and it's only worth 1 mark. That's a signal for a short, punchy, factual answer. But then Part 2 says explain an advantage for 2 marks. That word explain is a massive flashing light telling you to go deeper.
Seriously, whenever you see the command word explain, your brain should just go, bing, I need to say because. You have to make a point, and then you have to say why it's the case. An examiner is telling you flat out, a simple statement isn't enough for the 2 marks here. You've got to connect the dots.
Now, later in that same question, the command word switches up again. This time it's calculate. And that is fantastic news. Why? Because it means it's a math problem, and even better, they've literally handed you the formula on a plate. You don't have to remember it, you just have to use it.
Okay, for a 2-mark calculation, you've got to show you're working out. It's non-negotiable. So, step 1, find the area of one face. That's length times width. So 80 times 80 is 6,400. Step 2, a cube has 6 faces, right? So we multiply our number by 6, and that gives us our final answer, 38,400 nanometers squared. Easy marks if you just follow the steps.
And this just shows the difference perfectly. For the 1-mark give question, a simple fact like silver is strong is all you need. Done. But for the 2-mark explain question, we have a point, wood is a renewable resource, and then the reason, the because, whereas plastic is non-renewable. See? Point and reason. 2 marks.
Okay, moving on to question 2. Let's see how our golden rules hold up on a totally different style of question. This one's a mix of using the periodic table, reading data from a table, and figuring out what's wrong with a practical method. It's a real test of your all-round chemistry skills.
So, first things first, the question gives us this table. Before you even properly read the question, just take a second to look at the data. We've got symbols, atomic numbers, melting points. What do you notice? Maybe that huge jump in melting point for silicon? Or, look at the atomic numbers. 15, then 17. There's a gap there.
Okay, the instructions here are crystal clear. First, use the periodic table. That's a direct order. And for part 3, the command word is state. Now this is probably the easiest command word of them all. It just means look at the information and write down what you see. No fuss, no explanation, just the facts.
So the key here is, when you see the word state, do not waste your precious time writing a whole paragraph. The examiner just wants a quick, direct answer. Find the metal with the lowest melting point. Run your finger down the table, it's sodium. Find the nonmetal, yep, argon. Write them down, move on.
And now for the practical part. This is a classic exam question. Spot the mistake in the method. Notice it says, explain one change in each step. That is a huge clue. It means you need 2 separate corrections, and you need to explain the reasoning for them.
And here it is, laid out plain and simple. The student's mistake in step 3, well, hydrogen gas is way less dense than air, it's just going to float away. You have to trap it first. So you collect the gas in a test tube that's upside down, and then you do your squeaky pop test. For step 4, litmus paper tests a solution, not the air above it. You've got to actually dip the paper into the liquid to see if there's been a change. Both of those changes are absolutely vital.
Right, on to our final example for today. Question 3. This one is all about your practical know-how. It's asking you to take a basic flowchart and turn it into a detailed, step-by-step set of instructions that somebody could actually follow in a real lab.
Let's break this one down. The command word is describe. That's our main instruction. But hang on, look at the second part. Include the names of the apparatus needed. That right there is an absolute gift of easy marks. The examiner is literally telling you how to score points. Don't ignore it.
When you see describe in a practical question, I want you to think of it like you're writing a recipe. It has to be a clear, logical series of steps. What do you do first? Then what? What piece of equipment do you use for each step? It's all about painting a really clear picture of the whole process.
And this is what a perfect 3-mark answer looks like. We've got the steps in a logical order, and crucially, we've named the apparatus. We used a spatula, a test tube, and a dropping pipette. Each point is a clear action, building a perfect method that gets you all the marks on offer.
The last part of this question then asks what you'd actually see, and the answer is right there in the flowchart they gave you. It says that iron 2 ions give a green precipitate. Sometimes the answer is literally on the page in front of you. You just have to know where to look.
So let's take a step back. We've just looked at 3 really different questions, but we used the exact same technique to pull them apart and build the perfect answers. So let's boil all that down into one simple, super powerful strategy you can take with you into that exam hall.
This right here is your 5-step checklist for success on every single question. First, read it to get the context. Then, find and underline that command word. That tells you what to do. Circle the keywords. That tells you the topic. Check the marks. That tells you how much to write. And finally, build your answer to match the marks. It's a foolproof system, and it works.
So next time you open an exam paper, don't just see a scary page of questions. See a series of puzzles. And for every single puzzle, the instructions on how to solve it are written right there on the page. You now have the tools to decode them. The only question is, which one are you going to solve first?